Welcome back to another one of my integration example videos where I basically run through 3 examples. Each episode will get progressively harder and I'll show you more techniques. So far this is the second episode, and so these techniques will be harder than the first, but they won't be hard overall. Anyway, these are the 3 examples and I'll go through them in order. So we start with example 1, and we have fx equals sine of 2x. First we've got to find the integral of either side. So the integral of fx is capital Fx, and the integral we'll write using the integrand symbol on one side and dx on the other. So we're going to use substitution to solve this, and if you've watched my substitution video, it would say to do substitution you need a function times a function, but that's not necessarily the case all the time. So substitution is sort of like the reverse of a chain rule. So instead of finding the derivative of the outside then multiplying by the derivative of the inside, what we're going to do is we find the derivative of the inside here, sub that back in, and then find the integral of the whole thing. And that might be confusing at first, but if you've done substitution before, you should know how to do this. But anyway, what we're going to do is we're going to sub u in for 2x. Okay, that's going to make the new function look like sine of u, because it's much easier to find the integral of that dx. Okay, so now we're going to find the derivative of this, du over dx, which the derivative of 2x is 2. And because we have a dx isolated here, we can isolate this dx. So we'll have du on 2 equals dx. So we have the dx on its own, we have a dx on its own here, so we can sub this stuff in for this dx, which is here. So the new formula will look like the integral of sine of u du on 2. Okay, now because du on 2 is the same as a half times du, what we're going to do is we're going to bring that half out. Multiplication by a constant means that we can bring that whole thing out the front, right? So we're going to end up having a half sine u du, okay, because we brought that half out the front of this, because this is still the same thing, keep in mind. But multiplication by a constant means that's the constant, just the number. It says we bring it out the front of the integrand, because we don't want to find the integral of this. We want to find the integral of this. Therefore, we bring this out the front. And what we'll have is a half integral of sine u with respect to u. Okay. Now this is what we want, because now we just find the integral of sine u. Now the integral of sine u is negative cosine of u plus c. Now what we do is we just multiply the half in on both of these. We expand the brackets. So we'll get negative cos of u on 2 plus c on 2. Now I like these constants to be a single number, but this is correct. So I'm going to say h equals c on 2. Therefore, whenever I have a c on 2, I just put a h. Okay, now I'm going to sub back in u, because u we said is 2x. So cos 2x on 2 plus h is your final answer. Okay, now I'm going to do the second example. we have our function fx equals x cos of x squared. We're going to find the integral of both sides. Now, this might be a bit easier for you to understand with substitution. So, substitution generally, the other example was a different case, but in this case we have a function times a function, and inside one of these functions we have, inside one of these functions, which would be the cos of x squared, we have, if we derive that, we can eliminate this. And you may not see it, but when you do enough of these questions, you soon learn that you can. So we'll sub u in for x squared. Okay, and then we'll find the derivative of it, just like before, which will be 2x. And just like before, we'll isolate dx on its own by dividing both sides by 2x and multiplying both sides by dx. Now what we've got is a function that looks similar to this. The integral of x cos u multiplied by du on 2x, because we subbed in u for x squared and we subbed in du over 2x for dx. Okay, so now we can eliminate the x, because an x divided by an x is 1. So we're just left with a half, just like before. So we'll bring the half out the front. And what we're left with now is this. Now we just got to find the integral of cos of u. So we have half, multiplying that onto the integral of cos of u is sine of u plus c. Okay, we'll multiply the half in just like before. We'll have sine u on 2 plus c on 2. I'm going to state again that h equals c on 2. Therefore, sine of, I'm going to sub back in u. We said that u was x squared on 2 plus h. And that is your final answer. Okay. Now I'm going to do a third example. And this is going to be fx equals sec squared of x plus tan squared of x. Now I'm going to do this the long way so you don't miss anything, because I'm not just going to do your standard integration. I'm going to put in a trigonometric identity in here. That's what I've done. So first we will find the integral of both sides. Okay, now due to integration by addition, we can split these as such. These are just simple rules. You usually do them without thinking about them, but we will split them up and basically find the integral of each one separately. Now, what's the integral of sec squared of x? Well, the derivative of tan x is sec squared of x, therefore the antiderivative, or the integral, of sec squared of x is tan x plus c. Now we're going to have more constants with this, so I'm just going to call this c1. Okay, plus. Now, tan x is a trigonometric identity that says tan squared of x. Tan squared of x equals sec squared of x minus 1. Okay? And it's much easier when doing the integral like this than doing the integral like this, in my opinion. For me it is. So what we're going to have is the integral of sec squared of x minus 1 dx. Okay, and we're going to do just like what we did up here, we're going to do that to this. So we've still got the tan x plus c1 plus, now we're going to split this up using integration by subtraction. So x squared dx minus the integral of 1 dx. See, I used that, instead of having a negative 1, it's a minus the integral of 1. Because that negative, you bring that out the front. Okay, and then you multiply it back in once you found the derivative. I mean the integral. Okay, so we have tan x plus c1 plus, what's the integral of sec squared x? Well, we just said up here it's tan x. So we have tan x plus c2, because this is a second constant, minus the integral of x. Well, the integral of 1. The integral of 1 is x. Just like how the derivative of x is 1, same in reverse. So we have x plus c3. Okay. Now, I'm going to say that we're going to say that g equals c1 plus c2 plus c3. Okay? Therefore, it'll make this a bit more simplified. Because this c is still added onto that, and it's still added onto that. There's just some stuff in the middle. So, tan x plus tan x is 2 tan x minus x plus g. Okay? Because we have tan x plus tan x equals 2 tan x minus x plus c plus c1 plus c2 plus c3, or we said that this was g, so we're adding g. And that is the answer. That's the final answer. So thanks for watching. I hope you learned something, and have a good day.